Welcome to my channel. Today I am going to explain the next topic in the data structure subject, that is queue data structures. First, what is a queue? Queue is a linear data structure. Why we are calling it as a linear data structure means while inserting or deleting any elements from the queue, we will follow one order. That the reason we are telling that queue is a linear data structure. So here we are using the order that is first in first out order. So here this first in first out order means who will come first, they will serve first, they will go first out. So that's why it is called as Fifo order. And here there are two positions are there. First one is rear position and next one is front position. By using these positions, we can insert the elements and we can delete the elements from the queue. From the rear position, we can insert the elements. From the front position, we can delete the elements from the queue. Whenever we are going to insert the elements in the queue, rear position is incremented by 1. Whenever we are going to delete the element from the queue, the front position is incremented by 1 value. Here, to perform insertion and deletion, we have to use two methods, that is NQ and DQ. NQ is used to insert the elements in the queue data structure and DQ is used to delete the elements from the queue data structure. Next one, the graphical representation of the queue. So here initially you can see here from the rear position we can insert the elements into the queue. From the front position we can delete the elements from the queue. Here initially the rear position as well as the front position at 0 position. Why? Because here there is no elements are there in the queue, means the rear and front positions are both are equals to 0 position, means that will be at the 0 position. Now let us see the example one. Now we are going to insert the 4 elements. Those are 25, 10, 15 and 30. So here we are going to insert the elements in the queue. First step we have to draw an empty queue. Here we have to draw the queue without elements, means the position of front and rear positions both are equal. So rear equal to 0 and front equal to 0. Next, in the next step we have to insert the element that is 25. So the next step we are going to insert the element that is 25. After this one you have to draw the queue. Then here we have to use the method to insert the element that is NQ. So NQ of 25 means here on this the queue the 0 position is there. So rear position is 0 and front position is 0. So both are 0. And here whenever we are inserting the elements in the queue, first we have to see the rear position that is 0. So here in this position means in a 0 location that the 25 is inserted. So after inserting the 25 in the queue, the graphical representation is like this. So here the 25 is inserted at the position of 0. Next, in the next step we are going to insert the 10 element in the queue. So here we have to draw the queue and we have to increment the value by 1. here whenever we are going to insert the element, the rear position is incremented. So here the rear is 0. So we are going to inserting the elements, means here we have to increment the rear position, so that the rear equal to rear plus 1. So previously rear value is 0. Now we have to add the 1 value. So now the rear become that rear position is equals to 1 position. So at the 1 position we have to insert the next element, that is 10 element. So here to insert element we have to call the method that is nq. Which value we are inserting here? That is 10. So we have to write that is nq of 10. So in this queue, whenever we are inserting, the rear position is 1. So in one location that the 10 value is inserted. So here after insertion the queue will be like this. In the 0 location 25 is there, and at 1 location 10 value is there. Now the rear position is equals to 1. Next we are going to insert the next element in the queue, that is 15. So to insert the element, first we have to increment the rear value, then we have to call nq method. So here we have to draw the queue. Then we have to increment the rear position, that is rear equals to rear plus 1. Previously rear value is 1, and then we have to add 1. So rear equals to 2. So in this location, in the rear position location, we have to insert the element, that is 15. So to insert the element in the queue, we have to call the method that is nq of 15, means at the location of 2 location, the 15 will be inserted in the queue. So after calling nq method, we have to draw the queue, that is at the location of 2 we have to insert the 15. Next we have to insert the 30 in queue. So here previously rear position is 2. Then first we have to increment the value of rear, that is 2 plus 1. So here 2 will be incremented by 1, means rear equals to 3. Now here at the position of 3 position we have to insert the value, that is 30. So to insert the element in the queue, we have to call nq method, nq of 30. So after calling nq method, see here, after calling it, so at the position of 3 position the 30 will be inserted, means rear is equal to the position is 3. So and front position is 0 position. So here if you want to insert any element in the queue data structure, first we have to insert the element at 0 position. After inserting the element at 0 position, we have to increment the rear value by 1. Like this we have to insert the elements in a queue data structure. Now the next operation in the queue data structure, that is deletion operation. So in this deletion operation, for deleting any element from queue data structure, we have to use one method, that is dequeue method. From the dequeue method we can delete the elements, and after deleting the elements we have to increment the position by 1, that is front position. So front equal to front plus 1. Here you can see the example. So in this example we are going to delete 25 and 10 elements from the queue data structure. That the in queue data structure there are 4 elements are there, that is 25, 10, 15 and 30. So here rear position is 3 and front position is 0. So first step we have to check the front position. Front position is 0. Now we are going to delete the 25. So here, so we have to call the method, that is nq of 25, means if you call dequeue method, the 25 is deleted from that one, and here you can see after deletion how the queue will be like this. So in this position of 0 position the element is deleted. So here the front is 0. Now in the next step we are going to delete the next element, that is 10. Means here what we have to do, the position of a front will be incremented by 1, that is front equal to front plus 1. The front previous value is 0, 0 plus 1 means the front position is 1. At the 1 position of front the element is deleted. So at front position is 1 means at the position of 1 the value is 10 is there. So to delete this 10 element we have to call the method, that is dequeue of 10. So after deleting the 10 value from the queue data structure, that the graphical representation of the queue is like this. At the position of 1 there is no element, that the element is deleted, and front position is 1. Then here you can see while inserting the element and deleting the element, here we are using first in first out order. So the 2510 are initially inserted at first starting stage only. So here the elements are deleted in a first in first out manner. So first it deletes the 0 position, then it will delete the 1 position, after that then it will delete the 2 position, then it will delete the 3 position. Here we are following the order, that is Fifo order, means first in first out order. While inserting the elements also, here we are inserting the elements, that is also first in first out order, means here from the rear position we can insert the element, from the front position we can delete the elements. Thank you for watching.